Let's talk about doubly linked list now. Okay, so in case of doubly linked list, we have a struct node of this type where we have three values. One is int12, which means there is an integer in your node. So this is your node. Okay, so generally like this is actually like integer is the first number, but I'm showing integer as a middle number. That is fine. I mean that doesn't matter anything for us, right? Because for our purpose we will be accessing the fields of this struct node using the arrow operator, so it does not matter. I will be representing integer in the middle. And a second member is previous, which is a struct type pointer, and another member was the earlier one, as similar to earlier one, which is next, right? So previous is supposed to point to some struct node type of similar type, right? A struct node which is of similar type. This is also supposed to point to a similar type, right? So earlier we had this thing, but now we have the whole thing, which means we are also pointing to the previous thing. So why that is important and why that is useful, you will get to know within a few minutes. Okay, so suppose that this is the linked list that is given to us. Then in this case I will say that this is a doubly linked list. Why it is a doubly linked list? It is because that there are pointers which are pointing to, this pointer is pointing to the next node and this pointer is pointing to the previous node. Okay, this is why, because like this is called the doubly linked list. Now there could be many variations, which means like I can ask this pointer to point back to this. So I can say this is a circular doubly linked list and all, similar in case of singly linked list, right? So but if it is a vanilla or the plain doubly linked list, then this is pointing to null and this is also pointing to null. So next of this is pointing to null and previous of this is pointing to null, right? Now let me take one example. Maybe after that it will be more clear. Suppose that there is a doubly linked list given to you. So in this case, you will be having two pointers, right? So here also there are two pointers, and this pointer is previous because it is pointing to the previous thing. This pointer is next, this is previous, and it is actually pointing to null. Null means like it is not pointing to anything. And there is a little box or little pointer which is like generally we call it head, which is pointing to the first thing, right? Now similarly you will be having a complete linked list of this type. Okay, now just observe here that this last thing will be pointing to null. Now suppose that these are the few numbers. Maybe I can call it 1, maybe 2, maybe 3, maybe 4. Okay, now let me say that there is a pointer p. Okay, p is obviously of struct node type, which is pointing to this thing, and there is a pointer q maybe which is pointing to this thing. Now suppose if I want to access this 3, then what are the ways in which I can access this 3? Tell me. I can say q of value or q of data, whatever like the field name is. So I can say q of value, which is as good as saying 3. And what else? Can you access using p? I think yes. How? You can say p of next, right? P of next, which means p of next is what? Can you tell me? P of next is this, or like exactly it is what? P of next is this, right? This thing, right? Inside this is the p of val, this is the p of next, right? And you will say that this is a pointer, so it is as good as like it is a little box which is pointing to this whole thing, which is like 3, right? And you want to access this 3. How you can access this p of next, which is just to go here, and then you can say the whole thing is just a little pointer, right? Just like a p and q, and you can say the whole thing value. You may omit these brackets because it is anyway left to right, so that's why you can omit these brackets, right? Does not matter. So this is also 3. That's how you can access this 3. What about this 2? Yes, we can access this 2 using p. How? P of value, this is 2. Can you access this 2 interestingly using q? Yes. How? You can say q of previous. Q of previous is what? Can you tell me? Q of previous is this thing, inside this thing, right? Q of previous is this thing. So now that is a pointer. Using this pointer, can you access this 2? I think very easily you can say of value, right? So this is also 2. That's how we can access these values. Okay. And can you access this 4? I think we can easily access 4 using p, q, or maybe using head. I mean, using head it will be too much of next, but that is fine, right? So that's how we can access these values. Now let's see how we can insert a node in doubly linked list at a beginning. Okay, I want to insert at the beginning, which means I want this pointer to point to this and this pointer to point to this and maybe this to null, and then head should be pointing here. That's all I want. So instead of telling you the whole procedure and doing the step by step, I propose one thing. Let me propose this whole procedure as one question. Okay, So this is the question that is given to you, that consider the function below which inserts a node in the beginning with a given value. Okay, correct option should be chosen. So this is a function and which option is correct, and your code goes here, right? Your code goes here. So what are the options A, B, C, D which you can fill here such that this whole thing will insert a node at the beginning of doubly linked list? That is the given task, right? I hope you got it. So instead of me telling you the answer, I will all of you I will like all of you to try this question out and then tell me the answer. Okay, now you can pause this video and find out the answer. Okay, let me go through the options one by one. So first option is saying new node previous equal to null. So before that, let me quickly check what I'm doing in this function. I'm taking head as a head of linked list and then value which should be inserted, and I'm making a new node, maybe something like this, right? And this is a new node, okay, which is pointing here, and then I'm saying new node value equal to value. So whatever is this value, maybe 5, 10. So maybe this value I'm setting it to 5, and then I'm saying return head, right? Okay, so here some code should be inserted. So just check here, like I have some doubly linked list, some maybe something like this, and I want this to be inserted here, right? So maybe I can say that, okay, let me check option by option. It is saying new node previous equal to null, which means they are saying this should be null. Yes, yes, this should be null. So that line is perfectly making some sense. And then new node next equal to head. Okay, first they are dealing with new node. Actually I like this thing because dealing with new node is actually quite good practice, because if you are dealing with some head pointer and then all, then you may lose some information. But anyway, so new node next equal to head, which means this is pointing to whatever head is pointing to. So head is currently pointing here and it should be actually pointing to this. Yes, that is fine, awesome. And I think only one thing is remaining. I want head previous to point to here. Yes, head previous should be pointing to whatever new node is pointing to, and then I want this head to point to whatever this new node is pointing to. Yes, so I think option is perfectly making sense. So option A should be the correct option, right? I hope you got it. If there is any confusion, then you can comment it out, okay, or we will discuss in the doubt class. Okay, let's check the option B. So option B is saying new node previous equal to head. Okay, let me draw the linked list again, maybe at this time bit more clearly. This is the linked list that I have. Okay, and sorry, maybe something like this, and this is the new node that I have, right? And it is pointed by new node. Okay, now what I'm saying, this is actually null. I think previous thing is null. Okay, I have not set this null in this code, no problem. This is set. Okay, so new node previous equal to head. Oh, this line itself is wrong, right? New node, okay, but maybe later they may be rectifying it, no problem. So I cannot discard the option B just by looking at this line, because new node previously they are saying it should point to whatever head is pointing to, because head is currently pointing here, right? So that's fine. Now new node next equal to null, so they are saying that this should point to null, and head previous equal to new node, this should point to this new node, and head equal to new node, and head should be pointing here. Okay, so okay, I think I have done a bit messy, but let me draw it again. Sorry about it. See what they are doing. They are saying that this is new node. Okay, one second, let me put it aside so that I can draw the new node here. They are saying this is new node, and they are saying that new node previous should be pointing here. This is bit strange, but that is okay. This should be pointing to null, and they are saying this previous should be pointing here. That is fine. I think if they could have changed the functionality of these two, then this should work fine. And then there at the last they are saying head should point to whatever new node is pointing to. So ultimately head will be pointing here, right? And notice here that I'm returning head, which means I'm returning the address of this. So that is fine, right? Now is this a doubly linked list? Tell me. See, to be a doubly linked list, I have to maintain some consistency, which means that I see this is a previous, right, and this is next. Either I want next to point to all the nexts, or I want previous to point to all the next. Here this previous is pointing to this next, but this previous is pointing to previous. So the functionality is reversing, right? I mean, these names are not hard code, which means if I ask you whether this is a doubly linked list, then you may say yes, not based on these names, the previous and next. You have to say yes or no based on the consistency. See, this previous, if it is pointing to the next node, maybe like, okay, if the previous is confusing you, maybe you can say x, okay, and this next you can say y. If x is pointing to the next node, then this is x, this is y. Then this x should also point to the next node, right? So there is no consistency. That is why it is not a doubly linked list. Okay, don't get confused. It is not a doubly linked list because there is no consistency. Now you may ask that why this consistency is at all required. Just think about it. Why this consistency is required? Why I want this, if this x is pointing to next node, then why I want this x should also point to the next node? Why I can't work with this x is pointing to the previous node? Because suppose, let me just erase this. Because suppose that you are performing some operation on top of this linked list, then you are supposed to have some consistency. Maybe you are traversing the linked list. You can't traverse based on this x. Why? Because this x sometimes it is pointing here. If you're traversing, then it will be infinite loop, right? It will infinite loop. If you are traversing based on the x, then it will be infinite loop. So you have to maintain some consistency because you may want to perform some operation, maybe the traversal, maybe the counting the length of this linked list, or maybe some other operation. That is why you have to maintain some consistency, right? So that is why it is not a doubly linked list. Okay, that is why B is not the correct answer. That is fine. Now let's see C. In C they are saying new node. Okay, let me for the better illustration, for the better explanation, let me copy this C maybe, okay, to the next page, and I will explain it here. Okay, and let me remove these pointers maybe. Okay, okay. Now let's see what this C is saying. In the C I am saying that new node previous should be pointing to whatever head is pointing to. Okay, so this should point to whatever head is pointing to. Again, something wrong, but let's see if they fix it next. I think they are not fixing it because new node previous is never in the LHS. But anyway, let's see. New node next should be pointing to null. Okay, head next is pointing to whatever new node is pointing to. Okay, head next is this, right, is pointing to whatever new node is pointing to. Okay, some strange thing is happening. I don't know what is happening, but anyway, so head is pointing to whatever new node is pointing to. So I don't think this is a linked list, right? This is like, I don't know, this link is broken, and this is not even doubly linked list. Okay, similarly you can check D is also not a doubly linked list. Okay, so A is the correct answer. That's how you can insert at the beginning. I hope you like this question because I have basically, instead of giving you step by step procedure, I have made this as a question. Okay, now let's see how to insert at the end. Okay, so to insert at the end, you know that you have to traverse till the which point? You have to traverse till this point, right? So you may want to traverse here till here. Then you will say that okay, this should point here. I think that is quite easy. And one important thing is also to note here is that in this case, like whenever you are performing some operation that is not on the first node, I mean maybe some middle node or some end node, then you do not need to return head. Why? See, earlier if you notice that I'm returning head. Why? Because see, it was my earlier linked list, right? So it was anyway, like let me not draw all the boxes again and again. Maybe you will get it. Let me just draw one box like this. Okay, so this is my earlier linked list, right? And now I'm inserting a completely new node here. So head was initially pointing here, so obviously I have to return this address of this head, right? Because this is newly inserted node, so I do not know its address. So that's why it makes sense to return the address of this head. But if I'm inserting at the end, if I'm inserting, let's suppose my linked list is again like this, and I'm inserting at the end, then do I need to return something? Just think about it. Okay, if head is currently pointing here, and then if I'm inserting something here, no, I do not need to return because head is still pointing here, right? Okay, this will get more clear after this complete example where I'm inserting at the end. So let's just see how to insert at the end. Maybe I will traverse till this point, and then I will connect the dots. So before like instead of me giving you answer, so you should be able to solve this question. So consider the following function which insert a node at the end with the given value well, right? Now choose the correct option. So your code should go here. So just see what they are doing. They are inserting at the end, and they are basically creating a node, and then they are saying node value, and they are just setting the value, right? So okay, that is fine. Let me go to the next page. So what they are doing, they are basically this will be too much, I think. Sorry. So they are basically having a linked list. okay, something like this. And then they are saying that this pointer, obviously if this is a linked list, then this should be pointing to null, and they are making a node, right? They are making a node which is basically pointed by new node. Okay, they are naming it new node, no problem, new node, and new node is pointing here, right? And then they are setting this value, right? Now you want to traverse till this point. Let's just see which option is doing that. So to traverse till this point, what you want to do, maybe if head is pointing here, so can you tell me the condition? Maybe you can say, if you are traversing using head, you can say head next is not equal to null, right? So yes, this will make you point to the desired location. Maybe this will also make you point to the desired location, this will also make you point to the desired location. This is actually useless. I mean, the C option is completely wrong, because after this head will be actually null, and null next does not make any sense. In fact, it will be error. So C option you can straight away reject, right? Why? Because it is actually after this while loop it will be actually null, and null next does not make any sense. So that is why C option is actually wrong. Let me work with ABC. ABC seems a reasonable choice. Let's see which one is the correct choice. So new node previous equal to head. Now you are currently standing here, right? Your head is standing here. Now let me see option one by one. Maybe I can copy this A to the next page so that I can just show you clearly. So what they are saying, new node previous. So new node previous is pointing to whatever head is pointing to. Very good. Yes, I want this to point here. And new node next is null. Yes, that is also awesome. And I want head next to be point to whatever new node is pointing to. Head next should be point to whatever. Wow, this is done, right? So A is the correct option. So there is no problem. A is the correct option. What about B and D? Let's just analyze these two also, right? Let me probably copy this, and let's just analyze B and D. So maybe I can copy this B there so that it will be better, right? Okay. Okay. Before I analyze this, let me remove these links. Okay. So B is saying that I'm here new node next equal to head. New node next, which means this should point to whatever head is pointing to. Okay, this is something wrong. New node previous equal to null, so they are making it null, and head next equal to new node. Okay, so again there is some mismatch, right? There is no consistency. I mean, this is actually supposed to point to null, and this is supposed to point to the previous node, but it is happening in the reverse way, right? So they are asking it to point to this thing, and they are asking this to point to null. So that is why B is not the correct option, right? So you can say B is not the correct option. What about D? Let me quickly verify D also, and then we should be done with that, right? Okay, let's just verify D. So in D option, they are saying that new node. Okay, before I verify D, let me remove these links maybe. Okay. Yeah. So you do have only this new node pointing here, and this pointing to null, right? New node next equal to null and equal to head. New node next equal to head. Okay, again something wrong. Okay, new node previous is null. Okay, head next equal to new node head. New node head. This is not even complete. I mean a valid sentence, right? Maybe if it is new node next, then let me just try what will happen if it is new node next. Okay, head next, which means this should point to whatever new node next is pointing to. New node next is pointing here, so it should point to itself. Like, does not make any sense, right? So anyway, this is not even a correct option then. So D is not a correct option. So only A is the correct answer, right? Only A is the correct answer. I hope you got it right. So that's very easy. As long as you are able to analyze the things, then this linked list is actually very easy topic. Okay. Now let me move to the next thing, which is deleting the first node or any other node in the linked list. So let me start with the first node. So what do you think? If I want to delete this, then should I be traversing something or not? I don't think I need any traversal. Maybe I can just ask. Maybe actually delete it very easy if you are too cruel. Which means if you do not care about the memory leak and all, you can just say head equal to head next. That's all. I mean, you can just ask this head to point here, but yes, that is not a good idea, because that's a complete memory leak. So how to avoid this kind of memory leak? Maybe you can just copy this in the temp first. You can just say temp equal to head, and once you move here, then you can just say free temp maybe, right? Like that you can write a simple 2-3 lines of code. But anyway, I do have the question for you, and if you want, you can try it out quickly. Okay, let me know which one is the correct answer, and you can take a pause and solve this question. Okay, so this A option, let me analyze this. So they have defined a temp. They are saying whatever head is pointing to, temp should point to the same thing. Okay, this is the W linked list that I do have, and head is pointing here. So they are saying temp should point to whatever head is pointing to, and head should point to whatever head next is pointing to, which means head will start pointing here, and this link is now gone. And then they are saying that head previous equal to null. Yeah, that is also important. Yes, head previous equal to null. This has to be null, right? And then free temp. Yes, then this memory will be free. Free temp means what? Like free temp, see, if temp is pointing to something, then free temp does not mean that freeing the temp itself, which means that pointed by the temp, right? So whatever is pointed by the temp, right? So it will get freed. So I think A is very much correct option, right? A is the correct answer. What about the remaining options? Let me quickly verify the remaining options also. Okay, so before that, if I delete it, then it will be better because I can redraw it instead of making some adjustment in that. Okay, so let me redraw the doubly linked list, and I can analyze option B and option C, D also. Okay, so let's see what other options are saying. Here I'm saying head equal to head next. Oh, that's disaster, I think, because I'm losing this completely. And free, oh nice, I'm not losing it. Yes, I'm not losing it. So because that can be accessed by the head previous, so I can say free head previous. Yes, that's perfectly fine. I do not even need a temp. Wow, that's awesome. So yes, these two lines are perfectly good, and head previous is null. Yes. Okay, so B is also the correct option. I do not need temp, right? So why temp is needed if it is W linked list? Okay, so B is also the correct option. What about the option C? So let's just quickly verify the option C also. Okay, so option C is saying temp equal to head next, which means temp should point to whatever head next is pointing to. Let me just see. Like this is your W linked list, and head is initially pointing here. So temp should point here. They are saying, right? And free temp previous, yes, that is fine, free temp previous. But what about the head, right? This is, I mean, this could have been the complete the correct code if it is complete, right? I mean, if I can add something here, then it could be the complete code. Maybe I can just add head equal to temp, right? Sorry, head equal to temp. Yes, it will work, right? So I will ask the head to point here, and this is freed, and I will also ask the head previous or the temp previous to be null. So maybe I can say temp previous or the head previous to be null, right? If I can add these two lines, then I think this will be a complete code. I mean, this could have been the correct code if this is complete. So you can say it is an incomplete code, right? If you add these two lines also here, then it will be a complete code. Anyway, let me analyze the option D. Okay, so let me just copy it here because otherwise this will not be visible if I erase it. So I have copied this. Okay, so these are the two slides, and now I'm deleting it. Okay, now option D is saying free up head next previous. Okay, this is interesting. Free up the head next previous. Let me see what they want to say. Okay, this, let me erase it. Yeah, so this is your head, right? And they're saying free up the head next, which means they're talking about this. Head next is actually this, which means this address of this node. And previous means they're saying whatever the previous is pointed to. Previous means this. Oh, they're actually saying free up this. Yeah, fine, free up this. And then if you free this up, then how you are supposed to access this? Okay, that's wrong. Actually, head next is not valid anymore. Okay, why head next is not valid anymore? Because if you're freeing up this memory and head is currently pointing here, so now head is pointing to you have freed up this memory, and head is pointing to some invalid memory location, right? You have freed up this memory. You are not supposed to do head of anything. You can't say head value, you can't say head previous, you can't say head next, you can't say head of anything. You can't use this head. Head is now a dangling pointer. Okay, here head is a dangling pointer. We have discussed this in the C programming lectures, in the extract lectures. If you have not watched, then please watch them first. Okay, so anyway, that's not much required here. All I'm saying, if you just know little bit of information about the free, then it will suffice. Okay, so here head is a dangling pointer. You can't access this head next, so that's why D is a wrong option. I think A and B are the correct options. Okay, now let's see how to delete the last node in the doubly linked list, which means if I want to delete this, I think this should also be an easy, like if you want I can do it, otherwise you can take it as an exercise. Okay, like you need to traverse till this point, and I think you can delete it easily. So yeah, I do have this as a question, so let's just quickly solve this question, or maybe you can solve this question, I do not know. Like let me solve this question for the sake of completion, and you can pause this video and solve by your own. So you want to actually stay here, so while loop should be having head next. Okay, you want to stay here, right? Or you want to stay here. Actually it's a doubly linked list, does not matter. Like if you are staying here, you will go back and you will be staying, you will come back here, but anyway let me stay here only, right? So you want head next, which means this, of next, which means this thing to be null, right? You want head next of next to be null. Maybe B option is some good options, but maybe some trick might be happening in other options, but that's why let's just see these options also. Okay, C I can straight away reject, because head is not equal to null means here head will be null and these are not valid, right? C option I can straight away reject, but let me just see A, B and D. So A option is saying that I will be staying at the last, right? So okay, no problem. In A option they are saying that I will be staying here, because head next is null actually. Okay, no problem. And then head equal to head previous. So now, okay, now they are actually going back, and then that's the trick I was talking about, right? Now they are going back, they are saying okay, head equal to head previous, which means head, whatever head previous is pointing to, let this head also point to the same thing. Okay, so they are playing the trick, that's okay. And then they are saying free up the head next. So now head is actually, head is not pointing here. Okay, head is not pointing here, head is actually pointing here. Now they are saying free up the head next. That's very nice, I want to free up this, and then maybe head next equal to null, right? Yeah, A option is perfectly valid. What about B option? In B option, they are straight away coming here. They are not even coming here, right? They are saying head next not equal to null, and they are freeing up head next, which means they are freeing up this, and head next should be pointed to null. Yeah, B option is also correct. What about D option? In D option, they are saying while head next equal null, so this condition will be false in the first condition itself, right? So head is actually currently pointing here, head next equal null. No, it is not equal null, it will not even enter the while loop, and this is not making any sense. I mean, this is just a first node, head is just pointing to the first thing and not even pointing to the last thing. That is why D is also wrong option. So A and B are correct option in this case, right? I hope you got it. That's very simple if you analyze the things carefully. I mean, linked list is very interesting topic, and the major ideas in the linked list has been completed. We have finished singly linked list, right? We have finished all operations there, maybe insertion, deletion, and these printing length and these things. We have finished doubly linked list, we have finished circular linked list, right? These three things we have finished. Now there could be some other operations, maybe you want to traverse, you want to search something in the linked list, and these things, there are actually infinite things. Like I cannot have all the operations on the linked list, because these are the infinite things. So I hope these lectures are giving you the idea. Now you can solve any of the question related to linked list. Okay.